In this video, we are given graphs of sinusoidal functions, and we are going to come up with sine and cosine equations that model the graphs. To do this, we are going to use the properties of the graph to find the a, b, h, and v values. In the first question, we are asked to find two equations that model this curve. We will do one sine function and one cos function. To start off, we are going to identify and draw in the midline. So the midline occurs between the maximum and the minimum. So here the midline is simply the same as the x-axis. The midline is actually the v value. So here as the midline is y equals 0, we know that the v value is 0. This graph has not been vertically shifted up or down, so the v value is 0. Now we can use the midline and the max and min points to find the amplitude. So the amplitude is the distance away the maximum is from the midline, which will be the same that the distance from the minimum to midline is. So here the question states that the y-axis goes up by 2. Also, you can tell the scale 5 intervals is 10, so each interval is worth 1. So that means that the amplitude is 6 because the maximum is 3 intervals away from the midline and the minimum is 3 intervals away from the midline. So the amplitude is 6. It is important to know that we have only found the amplitude. We have not found the A value because the A value could be positive or negative. We are not able to decide if A is positive or negative until we find the H value. Finding the H value is the hardest step, and we'll do that last. So before we find H, let's find the B value. And to find the b value, we will use the formula b equals 360 divided by the period. Remember that the base sine and cosine functions has a period of 360 degrees. And then we're going to use the graph to figure out what the period of our transform function is. So I'm going to highlight one cycle of the curve. So I'll choose a starting point. Here the origin is a nice starting point. I would go up to the maximum, back down to the midline, then down to the minimum, and then back up to the midline. After that, I then start to repeat. So the purple highlighting shows one complete cycle, and we can see that the period is 180 degrees. So I can say that the b value is 360 divided by 180, which is 2. Just a couple notes on the b value. You did not need to start from the origin. You could have also started from the maximum and then drawn one complete cycle. So maximum down to the midline, to the minimum, back to the midline, and then back at the maximum. So here you would have started at 45 degrees and you would have ended at 225 degrees. The difference between 45 and 225 is 180. So it doesn't matter which point you start at to draw your cycle. Just make sure wherever you start is where you end before you figure out what the period is. And it is also interesting to note that the B value is how many cycles occur into 360 degrees. So if you were to continue this curve, it would have a minimum and then come back to 360. You can see that there are 2 complete cycles between 0 and 360 degrees, and that is related to the B value of 2. Now we only have the H value left to find. This is the most challenging step and will depend on if we are modeling with a sine function or a cosine function. We will do one of each here. Again, the question does ask for 2 different equations. So let's start with the sine function. With the sine function, you are looking for a starting point that starts on the midline. So we have the midline highlighted, and we can see that the curve hits the midline at 0 degrees. So there actually has not been a phase shift to the left or right. So that means that the H value is 0 if we were to choose this as a starting point for our sine curve. So we can then say that the H value is 0. It is important to notice that at that starting point, the curve goes up to a maximum. So that means there has not been a reflection. So we start at the midline and we go up just like the base sine curve does. So I'm just going to draw this to say we have our midline, the sine function goes up, down, and back to the midline. So that means the a value is positive 6. It is greater than 0. So now the equation becomes y equals the a value, positive 6, sine, the b value is 2, the h value is 0, so we don't have to write that, so we can just write 2 theta, and then the v value is 0. So I can just clean that up and write 6 sine 2 theta. The brackets aren't necessary there. So that is one equation that models this curve. Another one we will look at is a possible cosine function. For a cosine function, we're looking for a starting value at a maximum or minimum point. And we do this because if you remember, the base cosine function starts at 1. So at 0 degrees, the ratio is 1. Whereas the sine function at 0 degrees, it starts on the midline at 0. So the starting point is normally 0, 1 for a cosine function. So where is a maximum now? We moved 45 degrees to the right and we moved 6 units up. So there is this maximum that occurs at 45 degrees. So for the cosine function, h is 45 degrees. And because we started at a maximum, that means we are choosing a positive value of a, because there has not been a reflection in the x-axis. If we start at a minimum, the a value would be negative because that would have meant that we had a reflection. So a cosine equation would be the value of a is 6, cos, the b value is 2. Now we have an h value other than 0, so I'm going to put that double set of brackets, theta minus 45. Remember, brackets of lies, we have to do the opposites. So we subtract 45, and then end brackets, and then plus 0, so we won't have to add anything. So those are two possibilities that model this curve. Note that there are other possibilities. You could have started at 90 degrees for your sine function, but then the a value would have been negative. You also could have started at this minimum for a cosine function. Again, the a value would have been negative because there's a reflection. So the amplitude is always the same, although it could be a negative a value depending on the h value that you choose. The b value is always going to be the same between your sine and your cosine function, and the v value is always going to be the same. Only the h value is going to change, and again, your a value sign will change depending on the h value, the starting point that you choose. So let's look at another example. So here we have another sinusoidal function. I've drawn the midline. That equation for that midline is y equals 4. Again, the y-axis is going up by 2. So that means the v value is 4. The midline that is normally at y equals 0 has been shifted up 4. So we know the v value. The amplitude is the distance away that the maximum is from the midline and the minimum. So here the amplitude is 4. And then to determine the b value, we're going to take 360 divided by the period. So how long it takes for one cycle to occur. So I am going to have to start at this maximum and end at this maximum. I first thought of starting at this minimum, but I don't see another minimum on the curve. So I'm going to start at the two maximums. So I start at negative 90 and I am going to positive 270, which is 360 degrees. We could have started here at this midline, gone down and up and back down, again 360 degrees. So the b value is 360 divided by 360, which is 1. So now let's find the h value. So first let's choose an h value for a sine function. So we're looking at a point along the midline. So we can see that the sine function meets the midline at 0 degrees. So we can choose the h value of 0 again. But what's important to notice is that from that midline, the curve goes down, which means that there has been a reflection in the x-axis. So that means that the a value is negative. So just shown here, the curve goes down before it goes up and back to the midline. So the amplitude is 4, but the a value is -4. It's less than 0. So therefore, the first possible equation we have identified is y equals -4 sine b value of 1, theta minus 0, n bracket, and then plus the v value. Clean up inside the brackets. Don't leave it like that. That just cleans up to y equals -4 sine theta plus 4. You may have chosen a different h value for the sine curve. You may have noticed that on that midline, it meets the midline at 180 degrees as well, and then it actually goes up before it goes down, meaning there has not been a reflection. So another possible sine curve would be h is 180 degrees, but this time it goes up and then down, so a is greater than 0. So therefore, your equation this time could be y equals +4 sine b value is 1, which I'm not going to write, theta, take away 180 degrees, plus 4. So we have identified two possible sine functions that model this curve. Both would be correct. They both have the same amplitude. They both have the same b value. They both have the same v value. The h values are different, but they are both correct, and they match with if the a value is negative or positive. Now to model with a cosine function, we are looking for the maximum or minimum value on that curve. So we can see that there's a maximum value at -90 degrees. So that means h is -90. Because that is a maximum value, that means the a value is positive. It is greater than 0. So that means the function is y equals +4 cos. B value is 1, so I'm not going to write it. Theta plus 90 degrees. When you're putting it into the equation, remember the bracket of lie, so it's the opposite sign, plus 4. So the components of the cosine function are very similar to the sine function. Same amplitude, same b value, same v value. Again, just a different h value because we chose a different starting point. We could have also chosen +90 as a starting point. That is a minimum value on that curve. So we would say h is +90, but because there is a minimum, that means there has been a reflection in the x-axis, which means that the a value is negative. So therefore, y equals -4 cos theta. This time we're going to subtract 90 degrees. Again, bracket of lies, the opposite sign, and then plus 4. So in the second question, it only asked for two equations, and we gave 4, but I wanted you to see that there are different possibilities. So in the questions that you could be given, the question may not specify if it wants a sine equation or a cos equation, and you would just choose the one that you would prefer. Some questions might specify, write a sine equation that models this function, or it could say write a sine equation and a cosine equation that models this function. And in these equations, there's not really a lot of work that you can show. The marks really come in from the equation. Do you have the correct values, and is it in the correct form?